Okay, so a quick recap on stationary points. Today we're doing 8K. We're cycling back to chapter 8 and finish off chapter 8 with 8K and L before we move back to chapter 9, which is back to the antiderivative stuff. But don't worry, today it's just derivative. It's not too bad, I think. The questions are not easy, but yeah, these are the last two chapters for chapter 8. K and L, that's it. Alright? And then you guys will have completed everything from chapter 8, which is like A, B, C, D, E. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 chapters.
What was 8A?
8A was the chain rule. They're just recapping on the chain rule. I think they'll do that in like half a lesson. And we'll go all the way to 8K and L by the end of today, which is you guys will be ahead by like 12 chapters. No, 12 plus 4, 5, 17 chapters. Ahead of school, because your school is only at the end of chapter 6, and I'm assuming you guys are okay with chapter 6 so far? Yeah? Sarah? Yeah? Any question for me from chapter 6?
No, really, I just don't like application questions.
Okay, I'll cycle back to the application question a bit later before the exam.
Not today.
Not today, yeah. Charlie, how are you going with chapter 6?
I just hate graphs.
Okay.
So stupid. Hey, graph this, graph that. No.
Yes.
And where do they just make up stuff from?
What do you mean make up stuff from? Like what stuff?
Like, they give us a rule to use, or they give it, you know, like the formula for like an exponential, like A equals like
Oh, yes,
like
yes.
E negative KT.
Yep, yep.
Yeah, but then they go, but you don't have to use E. Like, then don't give it to me like that if I don't have to use that. They go, yeah, you can just make it up. Like, then don't give me the standard one.
Yeah, well, what they said is not technically wrong, but normally you don't really need to know that. You don't normally need to know that. But anyway, I'm not going through chapter 6 right now, okay? I will just let the school deal with that because chapter 6, the main purpose is to prepare for chapter 8, which is by giving you guys what the Euler's number is, the number letter E. It's a special number, okay? But anyway, we've already gone through all of that, so let's go to stationary points. Okay, stationary points. I probably will go through both the easy and the harder type questions. Okay, because last time for the antiderivatives, I just went through the easy ones, but I think this time I will have to go through both the easy and the harder questions for this chapter, because technically it's not a new chapter. You guys already know what stationary points are. Sarah, what's a stationary point?
Where like derivative equals 0.
Yes, correct. It is a point where the derivative equals to 0. So, okay, so let's go through stationary point. Okay, there are many ways of explaining it. First is the derivative, right? Derivative is equals to 0. Another way of writing derivative is?
F dash of X.
Very good. F dash of X equals to 0. And another way is?
dy over dx.
Yes, dy over dx equals to 0, right? These are all the same thing. And there is something else about stationary point that is not from about the derivative, but it's about the meaning of the derivative. What does it give you?
Turning point.
Yeah, turning point. It is a turning point.
Improv.
Okay, a turning point. That's not wrong. I'm looking for something else.
What does it start with?
G.
Gradient.
Yes, the gradient is also equal to 0, right? Or horizontal gradient. Gradient is horizontal. Okay, so when the gradient is horizontal, how many types of stationary points are there? I'll sort of go through this as
When
well.
the gradient's horizontal, there's...
How many types of stationary
there's
points?
like the local minimum, local maximum,
Yep.
and then at the turning. No, it's the one in the middle where it goes bloop, bloop.
Yep. What is it called?
It is called... Oh, it's the funky one.
It's not on that sheet. It's the next sheet. I haven't given it up to you guys yet. So you won't find the answer there.
Where does it start with?
It starts with stationary point of something.
It's inflection.
Yes, stationary point of inflection. Remember these ones, Sarah?
I don't remember the last one.
Okay, I'll go through the last one. So the local minimum is like that. It's easy, right? And local maximum is like that. Stationary point inflection, there are two versions, okay? The first version is when it will have to be horizontal gradient at the point, right? but then you could have a going down and then going down again, or you could have going up and then going up again. Okay, so these are technically 3 types of stationary points. The last one just have 2 versions, the stationary points of inflection. Okay, and the technique to find out the nature of these stationary points in Unit 3 is called the gradient table. Okay, so the gradient table, how does it look like for the local minimum? So the gradient table will normally have the x and then the f dash value,
And
right,
the
and then the shape. Correct. Okay, so how would it look like for the local minimum and local maximum?
Or you just pick whatever numbers you want.
Yeah. So actually, I'll just okay. I'll just show you guys the general idea. So the shape for the local minimum would be coming down and then horizontal and then coming up. Alright, so these would be the 3 shapes here for the local minimum, and local maximum has to go up and then horizontal and then down. Alright, for the shapes. Okay, which means going up means the gradient is going to be positive gradient and then 0 and then negative gradient. Okay, and then the other one for local minimum would be negative, 0 and then positive for the gradient. Okay, roughly that's how the number should look like. And then stationary point of inflection, there are 2 versions. The first one would be down, horizontal, and then down again, or you can have up, horizontal, and then up again. In this case, it would be negative, 0, negative, and this one would be positive, 0, and positive again. Alright, so these are the shapes and the gradient. I swapped them around, but should make sense, right? Okay, so that's it. That's all of the main concepts I need to recap for you guys. Let's go through Beshu. Let's go through the some questions here.
Yeah.
How confident are you guys with doing, say, questions from this one? So many examples.
Which one?
Alright, question 1. 8K question 1. Find the stationary points of each of the following. I will pick the question for you guys. You guys don't need to do all of these. The one I want you guys to try out is question... The first one is A.
Question 1A.
Question 1A. And then the next one will be question 1... Let me see this. 1A, 1C, and 1H. Alright, it's these 3 questions here. Okay, so if you don't want to spoil yourself, just mark these questions on your sheet and just start working through them, because I will start working through the answers now. I won't explain them though, unless you need any explanation, because I'm assuming you guys should remember how to do the derivative, right? Sarah, what's the derivative of e power x?
E power x.
Yep, the same thing. Charlie, what's the derivative of sin x?
Pardon?
What's the derivative of sin x?
Sin x?
Mm-hmm.
Negative cos x?
No, sin just becomes cos. Positive.
Oh.
Right? Because sin is the first one and cos is, you know, like, is positive. What's the derivative of ln x, Sarah?
1 over...
Yeah, 1 over...
Is there a range for these or no?
1 over x, yes. Sorry? No, there's no range.
Because if you get like plus, if you get square root of 4, it's plus minus 2.
If you have x squared equals 4, then yes, then x is plus minus 2, correct. So it's plus minus square root of 4. And yes, Sarah, deriving ln x is 1 over x. Right? And then if it's ln of a function, then you have to use the chain rule. So if you do, okay, when we get to that question, you'll see.
So do I have to do... Do you have to do one for both 2 and negative 2?
Correct.
So what numbers would you pick like between the two?
So the table will look like this, right? You should set it as a lower value first and then a higher value, and then you can fill in the basic ones. add those ones because they are where the first derivative is equal to 0, so the gradient is horizontal. You can pick any number before and after, but the easiest one, like the number between them, the easiest one would be
1.
no,
Not 0.
0 is the easiest one. Okay, and of course the number before and after you may or may not want to use like a whole number, like I think, yeah, let's just go -3 based on this question here, because sometimes you might want to pick a number like -10, right, depending on the equation. Sometimes when you pick a power of 10, because the equation has like a decimal number, it will make it nicer, right? But in this case, just pick -3 and +3. So another question won't ask you to find the stationary points, means you also need to find the y coordinates, right? So the first answer here is only the x coordinates. You also need to find the y coordinates. Oh, and technically this question you don't need to do the gradient table. I'm just showing it here, but it's optional. Yeah, they're not asking you to find the nature. Next chapter is when you have to find the nature. Right, so the final answer for question A should be 2 points, right? 2 points with both x and y coordinates. Two -16 and -216. Okay, and when you're done, move on to C and then H. Remember, you don't need to do the gradient table, yeah? Just find the y coordinates and you're done.
Wait, what do I do from here, Corey?
Which one? Question B? Question C?
Whoa, how do you do that?
Which line?
The fourth.
The fourth line? You take out, so divide both sides
I
by...
took out the 20.
Yeah, and then you can divide both sides by 20. 0 divided by 20 is 0.
Yeah, so then I have x cubed minus x4.
And you take out common factor.
So smart. Corey.
I'm just used to it. Okay. Make sure you use the right notation, yeah? Question C is h of x, so don't use fx, it should be hx.
I don't like h of x.
You see some weird notation later. Any questions, Sarah? Okay.
Isn't it
Yep.
because if you have -1 to the power of 5 is -1.
No, it should be positive 1.
This is positive 1.
Mm.
Why is this positive 1?
Because 1 minus x equals 0. So x must be 1, because 1 minus 1 is 0. Alright, so when you get to this point, when you shift the x over here, 1 equals x.
Oh, okay.
Yeah?
Okay, close enough.
But you will lose half the marks
No, it's
at the end.
it's alright.
You should fix that one up. 0, 0, and 1, 1. And then question H. So this question 1 is simple familiar because it's just supposed to be a recap of the Unit 2 stuff. The next question, I'll go through some examples first and then you guys can try out the next question. Hopefully, when you get to these topics at school, you guys wouldn't have forgotten everything, right? Alright, that's the end for question 1A, C, and H. Alright, let me start with example 34 here. So these are the new functions that you guys learned for Unit 3. Okay, and note that what is the rule for question C?
ln.
Yes, that's one thing. ln is one rule. What's another one?
Maybe you put it to the power of x, like ln 2x.
Not quite. It's a rule from Unit 2.
It's a good one.
Starts with P. Something something rule. Recognize it? It is a product rule. Why is this a product rule?
I don't know. I just said it because it started with P.
It's a product rule because you have two functions of x. You see, this is x and then times by ln of 2x. Alright, you have two functions of x, that's why it's a product rule.
Isn't it the same as saying 2x
To the power of x, yes, but you don't want to do that.
Why not?
Because you can't derive 2x to the power x. You don't know the rules to do that yet.
Do you know?
Pretty sure you don't.
Yeah.
It's very complicated. Like can you? No, I can't be bothered to think about that. So the easier way is just to use the product rule. Okay, for question A, y is equals to sine 2x, then we need to derive it. Charlie, what's the derivative?
Wait. Let me write down example 34 so it's all organized.
Alright.
Cool, you're gonna be so proud. I actually watched your recordings.
Oh, perfect. Thank you.
I had to.
Thank you. So I'm not just recording for no one to see. Perfect.
No, it was lovely.
Thank you.
Okay, wait.
Did you get it though?
I did get. Well, I watched the one from the first week I missed. I watched that one. I haven't watched the second one yet, but I watched the first one and that one made sense. It was like it was this thing.
Oh, yeah.
It was like the complex question one.
Yeah. Okay. And then there was I think that was last week, right? Complex question for 9D and E, right? I think that was the one you missed. Like the one before that was way before that. I don't think you.
The one from the 16th of the 7th was complex questions. It was 9B.
Yeah,
and then
okay.
C. And
Yeah.
then
Yeah. And then the most recent one is D and E.
yeah.
Yeah, but you haven't watched yet.
No, I haven't actually.
You need to watch that one as well.
But I've watched one of them.
Okay, good,
And
very
I
good.
think
That
I should
is.
be grateful that I've watched one.
Yes, I am very grateful that you actually watched my recording, Charlie. Okay.
Right, equal.
But yes, what is the derivative? All right, Charlie, too slow. Sarah, what's the derivative for question A?
Is it like it's 2 cos 2x, right?
Correct. It is 2 cos 2x. Sarah, why?
I don't like these ones.
Explain.
Don't you have to multiply it by 2 because you derive what's inside?
Correct. That's the correct explanation. So yes, it is 2 cos 2x. When you set that equals to 0. When you set that equals to 0, and then you divide both sides by 2, how do we solve this one? Note that we've got a domain which is x is between. Maybe I'll do this one later. We need more space. So the domain is.
You find
Come on, pen.
when is cos 0.
Yep, correct. And when is it?
Well, koi, actually no, you divided out the 2 at the bottom.
Yeah,
When
so.
is cos 0? It is 0. Cos is x, the x-axis. So pi on 2.
Good. That's the first one. Very good. Pi on 2. There are many solutions here though.
Pi on 2.
Wait. How many solutions would there be?
There should be 2
Incorrect.
or 4.
Why 4?
Oh, because you have to multiply the thingy in front.
Yes, this is the domain for x.
I never understood that, but I still don't understand. I'm going to be honest with you, Koi.
Okay, actually, we have some time. Let me spend some time explaining this again. So, is this step here to multiply the domain, to get the domain for 2x, right?
But why can't you just divide them by 2?
Because we want to get to 2x. And to get 2x from x, you have to multiply by 2. And when you multiply one side of an inequality, you have to multiply everything.
But why? Because if it's 2x on there, why don't you just write down the thing and then you divide them by 2? It's just why do you have to change the domain?
Okay, good point. Let me go through this domain thing. So let's just say that, let's consider whole numbers, right? Let's consider whole numbers, right? And then let's just say that x must be between 0 and 3. Okay, so what are the values of x here? Whole number between 0 and 3 would be 1 and 2, right? Okay, now if I were to find out, okay, what are the possible values, what are the whole numbers of 2x that it will still satisfy this one. So when you multiply both sides by 2, right, it will be 6. So then what are the possible values here for 2x between 0 and 6? Well, the answer for 2x would be 1, 2, 3, 4, and 5, correct?
Yeah.
Yeah, but then when you divide them by 2, you get this one as 1/2. We're not taking that because we're only taking whole numbers, right? And then this one will be 1, and then 3/2, we're not taking that either, and 4/2 is 2, and then 5/2, we're not taking that either. So you see, it turns into the exact same thing, right? Does that make sense? It still turns into the same thing, but it will cover, actually cover all of the possible values. If you're thinking of all the values in the real number, so it takes decimal and anything, then when you multiply x by 2, you need to multiply the other sides of the, of the inequality by 2 as well.
Okay.
Does it make a bit more sense? Maybe? Okay. Put it this way. Another way to interpret this question is this. Do you guys remember the concept of period? The period of a sine function. What's the period of a sine function?
The period of sine function.
Oh, cos function. What's the period of a cos function? Okay, it's been too long ago. All right.
It's something important.
It is something important, yes. So, okay, I'll give you a quick recap. Technically, it's about graphing. So, Charlie, I know you don't like graphing, but this is why knowing graphing will help you understand a lot more concepts. So, graphs of sine and cos. Okay, it's time to revise this. So, the basic sine function would have a graph that starts from the center, goes up, goes down, and then goes up again, right? This is one cycle for sine of x. Remember this? Yeah, and one cycle would start from 0 and ends at 2 pi, right?
Yeah.
The basic one is 0 to 2 pi. And what's the range? It goes from what to what?
1 to -1.
It goes from 1 to -1. Very good. Okay. Now for the cos function, if I want to draw one cycle for cos of x, it starts at 1. Very good. It starts at 1 and then it goes down. Now there will be these points here. What's the point? What are the points in the middle here?
The thingies.
Pi over 2.
Yes, pi over 2. Yep.
3 pi over 2.
That's right. So if you notice, remember the idea of a quarter period? Yeah, a quarter period is the gap between the 2 points, between each of the main points, right? Yeah, that's a quarter period. So now we can draw the cos graph, goes from here to here and then down a little bit and then come back up and then finish up top here. Okay, so that's a cos graph. Now, if I were to draw, so that's a quick recap for sine and cos graph. Now, we need to look at cos of x versus cos of 2x. Right? The difference is that the second graph has 2 times into the x here. What changes? What does this one change? The 2 times into the x here.
Period.
The period, correct. What's the period now?
4.
The period is 2 pi over b.
Pi.
It's 1 pi, correct? It's 2 pi over 2, which is pi. So what does it change? What does it change when you have cos of 2x? Let's have a look. So the graph is still here. I'm just going to have 2 pi over here and then pi in the middle because we will need this bit here. So that's pi here. So note that the original graph will still go from cos is from here and then to pi over 2, right? To the middle and then to the bottom, then to the middle, then to the top again. So I'm going to draw this blue graph, right? And this is the graph of cos of just x, right? Basic one. Now, the period is pi for cos of 2x. What does that mean? It means that it has to complete one full iteration in pi time, right?
Yeah.
And pi is roughly around here. So you see why I had to stretch it out? Yeah. Because then now I have to draw this graph, the cos of 2x graph. It starts from 1 again, but it goes to this point here, right? And then it has to go down to this one and comes back up, and then it has to finish in pi time. So you see, it's cos of 2x, but it actually finishes one cycle in half the time, right? And that means that in the same amount of time, like 2 pi, you will actually have how many cycles?
2.
2 cycles, that's right. There will be 2 cycles. So how many x-intercepts will there be?
4.
4 x-intercepts as compared to the original, which only has 2 x-intercepts.
Yep.
Does that make sense?
Yep.
Yep. And so now, if you're looking at the original, if you're solving 2 equations, where the first one is cos x equals to 0. What are the angles? Right, and I'll write this in blue. So cos of x, the blue graph, equals to 0. What are the answers? What are the x values?
Pi on 2.
Pi on 2 and?
3 pi on 2.
Very good, and 3 pi on 2. All right, 3 pi on 2 here. But if you were to solve the red one, so cos of 2x equals to 0, right? If you try to look from the graph, it's not that obvious, right? If you want, you can still use the graph, so that's pi on 4, and you count. This one would be 2 pi on 4, 3 pi on 4, 4 pi on 4, and so on and so forth, right? It's just how many pi's on 4 there, right? So technically the answer using the graph, you can get straight to the answer, and what would they be?
Pi on 4.
Yep, so x would be pi on 4,
3 pi on 4.
3 pi on 4,
5 pi on 4.
yep,
And 7 pi on 4.
and 7 pi on 4, right? But you see, in order to solve for this graph here, you need to actually, to solve this one, you need to draw a graph, and then you have to like read off the answers and stuff. The easier way is to use the technique that I said earlier, which is to change up the domain, okay? So the domain for x is 0, x is between 0 and 2 pi, right? So, hang on, I'll write this in blue. So the original domain will be for x. Now we want the domain for 2x, okay? And when you multiply an inequality by 2, you're multiplying everything by 2. All right, that's actually just an algebraic step to 4 pi. So this is just essentially saying that if you're solving for 2x, it goes from 0 to 4 pi. You have to find answers from 0 all the way to 4 pi. Right? Because then you have 4 answers, right? 2 cycles, 4 answers. And then when you divide by 2, then you will get the right answer. So you see, for 2x, again, we're solving for 2x, so you get 2x equals to, now if you're not looking at the graph and looking at only at this domain here, it goes from 0 to 4 pi, and we'll find what values of this would give cos equals to 0, and then you can just think of, oh, cos equals to 0, cos is here, and 0 would mean the top and the bottom points, right? And so that would give you pi on 2, 3 pi on 2, and then you need to add 2 pi to each of these answers here. So that would be, the next one will be pi on 2 plus 2 pi, and then 3 pi on 2 plus 2 pi. Why do we add 2 pi here, Sarah? Why would we not minus 2 pi?
Because it doesn't go to a negative.
Yes, the domain doesn't go to negative, but it goes past 2 pi to 4 pi. All right, so it goes to the next cycle. Does it make sense so far? Yeah. And then if you were to solve this one, you would get 2x is equals to pi on 2. How do we add 2 pi? How do we do this one here? Pi on 2 plus 2 pi.
Wait, why are we adding 2 pi?
Because there are 4 sides. If we're solving for
I
2x.
don't like this way. Can we just do the fun way? Let's do the normal way.
The graph one?
No.
Yeah, this is the normal one.
Well, why are we adding 2 pi?
Because there are 2
Oh, for
cycles.
The next cycle.
Yes, for the next cycle.
I just kind of go, oh, what would it be in the next cycle? I don't really think about adding 2 pi.
Well, it's the same thing.
Instead
It's the
of-
next cycle, you add 2 pi, yeah.
It's just 5 pi on 2.
Yes, it is 5 pi on 2. Now, this is the math, right? When you're adding 2 pi is 2 pi over 1. And because the denominator is 2, it will be 4 pi over 2. So that's why when you add to 1 pi, the answer is 5 pi over 2. Yeah? Make sense? Yeah? So you have to convert the whole number 2 pi into a fraction, and then you add them, just adding fractions. So 5 pi over 2. And then when you add this one, alright, again, you're just adding 4 pi over 2. So that'll be 7 pi over 2. Make sense? Yep. And then when you divide everything by 2, you're just multiplying by 1/2. So you're changing only the denominators to 4s, and that's it. So final answer. Does that make sense? This is the unit 4 stuff.
Yes.
The last question was easy. This one is not so easy.
This one was alright.
Alright? Okay. That's good. You guys will get to do some questions like this later.
No, it's okay.
Yes, I'll do some of these questions later. But yeah, so going back to this one here, the answer will continue in this section here, and then after that you still need to find the y coordinate. Now there is a little trick to find the y coordinates, make things a little bit easier. So remember the equation is y is equals to, what was it again? Sine 2x. Okay, y is equals to sine of 2x. Right? The trick is, note that this is 2x in here and we already have the answers for 2x. Alright? Okay? Ultimately, we use this one as an x coordinate, but we already calculated, we have the calculated version of 2x, right? Because if x are those ones and 2x are just these values here. So that means that when you substitute the x in, the y values would just be sine of pi on 2, sine of 3 pi on 2, sine 5 pi on 2, which are essentially the 2 points here. And sine of those ones, you can actually read that off of this graph here.
Okay. It's the exact values, right?
Correct, it is the exact values. And so if you're comfortable, you may not even need to actually, okay, I'll show you this version here. So you've got x, and then we've got 2x, and then we've got the y value. Okay, so the x values are these ones, the pi on 4, and then 3 pi on 4. I'll just show you one or two versions. 2x would be the one above that, which is pi on 2, right? And sine of pi on 2 is this coordinate here, this point here. Sine of that is 1, correct? So the y value will just be 1. Okay, and then for 3 pi on 4, the next point, 3 pi on 4 here, then the 2x version that corresponds to that is 3 pi on 2. Alright, so what's sine of 3 pi on 2?
-1.
Is -1. So you see, it just alternate between 1 and -1. I don't even need to try to manually calculate the other ones. Does it make sense?
Mm-hmm.
Yeah, so then I can just write the final answer. If you can see it, the final answer would be pi on 4 and 1. Alright, that's the first point. The second point is 3 pi on 4 and -1. And then the next point would be 5 pi on 4, and this time it's +1 again. And then the last point would be 7 pi on 4, and the y coordinate is -1 again. It's just alternate between +1 and -1 because it's essentially just these 2 points here. Does that make sense? Yeah? So this is a stuff that your teacher will not go through at school, right? If you get it, you can do the question. If you don't get it, GG. Just give the mark, just lose the marks. Okay? Normally schools don't go through this content into this detail. Any question before I move on? No? Okay. Moving on. I might just paste example 34 down here again. Don't worry, you guys, you will get to try these questions later. It's just question 2. It's funny because this chapter has like 13 questions and we're only at question 2.
That's so funny.
It's not. This is the last 2 chapters of Unit 3 derivatives. So of course it's going to be a little bit harder. Okay? The last 2 chapters. And because after chapter 8 is chapter 9 and 10, which is only anti-derivatives. Alright? This is the last 2 chapters of derivatives in Unit 3. Alright? So these questions are very similar to what you would get in the exam. Just remember that. Now for question B. Y is equals to e to the power 2x minus x. Derive this one for me, anyone.
2x, no, 2e, 2x.
Yep.
Minus 1.
Very good. Any questions, Sarah? No? Okay. So now we need to solve for this equals to 0. No, don't worry. The next 2 questions will be a little bit easier. It's not as troublesome as trigonometry. By the way, this stuff there that I just went through with you guys, I literally went through this with one of my grade 12 last week because I forgot about all of this stuff already. Okay, so I will most likely have to go we'll go through this again with you guys next year. Anyway, so 1 equals to 2e power 2x. Divide that by 2. 1/2 equals e to the power 2x. Okay, so then ln of 1/2 would be 2x. Okay, so then 1/2 ln of 1/2 would be equals to x. Yeah, okay. And then they would change up the ln 1/2 into ln of 2 to the power minus 1. and then bring the power to the front just to not have a ln of a fraction. So negative 1/2 ln 2 is equals to x. Okay, now wait a minute. Now we need to find the y. So there's only one x coordinate there's only one turning point. Now you find the y coordinate. We have to use a little bit of a trick here. Okay, so y coordinate, y at x equals to, so we substitute x equals negative half ln 2. Now note that you are substituting two things. Okay, this is the new stuff. This is new stuff, guys. The equation for y, what does it look like? Y is e to the power 2x minus x. Now I'll show you the bad version first. Okay, just to show you how painful it is if you don't know the smarter version.
Yes.
So the bad version is, okay, I'm going to substitute this thing in. So that will be e to the power 2 times negative half ln 2. Do you want to calculate this thing? No, you don't want to calculate that thing, right? I don't want to calculate that thing. So instead of substituting the x value only, well, we need this one because we need to substitute this value into the x here, right? So we still need the actual x value, but the e to the power 2x, we had the version of that before, right? Yeah, does it make sense? So sub x equals to that, and what's the value for e to the power 2x? It's just 1/2. Does it make sense? Yeah, so then that would just be 1/2 minus negative 1/2 ln 2. So that would just be 1/2 plus 1/2 ln 2. Much more convenient, right? So that's why when you're working with exponential equations, e to the power something, right? Because when you derive it, you get the exact same equation. At some point in your working, you will have a substitution version that's easier to work with than the final x version. Yeah, but you still need to find the final x version because that's the x coordinate. So then the final answer, therefore, the coordinate would be negative half ln 2, and the y coordinate will be, I'll use a different color here, half plus half ln 2. Okay, so this is the final answer. There's only one coordinate, but in the tech-free version, you have got to write it in this form here. Make sense? Okay? Alright, last one is question C, and then we can get to these complex familiar questions. So x ln 2x, what did I say earlier? What's the rule here? What's the rule here? There were two. The product rule, yes, that's the main one that I'm looking for here. Product rule, Sarah, do you still remember how to do product rule? What's the product rule?
Isn't it like multiply u v plus
Yes.
u? Wait, the first u is derivative.
Correct, so u dash.
V and then plus u v dash.
Yes, that's right, that's it. That's the product rule. Okay, you always derive u first. Remember, Sarah, you're the one who forgot this one and you messed up your quotient rule. Always derive u first. Okay, so in this case, I'll write u as x and then v as ln 2x. What's v dash? We'll do the hard one first because u dash is just 1. What's v dash?
2. Oh, no.
1 over 2x times 2.
Yes, it's 1 over 2x times 2, and then the two 2's cancel out, so it'll just be 1 over x for v dash, yeah? Okay, so then y dash would be, you sort of multiply them across like that. So u dash v, so that's 1 times ln 2x, and then plus x times 1 over x, which is conveniently turned into ln 2x plus 1. Okay, yeah, so that's y dash, and then we solve y dash equals to 0, ln of 2x plus 1, so then minus 1 equals to ln of 2x. How do we continue here? How do we continue here? Anyone?
Not sure.
Sorry?
Not sure.
Not sure?
Do you do like exponential?
Yes, you turn it to exponential. How?
E to the power of negative 1 equals 2x.
Yes, that's right. Does it make sense, Sarah? Yeah, so you start with the base always. Ln is just base e. And then raise to the other one, which is minus 1, and then equals to 2x. Yeah, so That's 1 over e is equals to 2x. Right? And then divide both sides by 2. I have 1 over 2e equals to x. Okay? Yeah. Once again, let's substitute. Let's find the y coordinate next. So y coordinate. And note that y is equals to, what's the equation again? X ln 2x. X ln of 2x. Okay, what are we substituting here?
X equals 1 over 2e.
Correct. Sub x equals to 1 over 2e and
E negative 1.
not quite. There is an easier. There's a better version somewhere here.
E to the power of negative 1, right?
No, there's a better one.
1 over e.
Not quite. So we need this one here, right? There's another.
Negative 1.
Yes, you substitute the entire ln 2x equals negative 1. Right? Because all of these are equivalent, right? That one is equivalent to this one. So you actually can just sub that, and then sub ln of 2x is straight away equals to negative 1. Then you have y is equals to 1 over 2e times by negative 1. You don't need to deal with some weird calculations here. I will show you that anyway, just so you guys, if you ever forgot about this substitution, you can still work it out. So the final answer would be 1 over 2e and negative 1 over 2e for the coordinate. But I'll show you what happens when you substitute only the x equals 1 over 2e. It's a fun, okay, so note sub x equals 1 over 2e only. Okay, then you would have y is equals to 1 over 2e, which is the same, and then ln of 1 over 2e. Now, how do we work with something like this? Sorry, it will be 2 times that, so that'll be 2 over 2e. Okay, so first the left hand side is the same, and then 2 over 2e simplifies into, change my color, 1 over e. How do we continue?
Then it's e to the power of negative 1, and then you bring the negative 1 to the front. And
Correct.
Cancel that.
Yes, very good. Yeah, so you see, you still can work it out. It's just not as, I guess, convenient. ln e, right? And then what's ln of e?
1.
Is 1. Yes, so that'll be that times negative 1 times by 1, which is going to be the same, negative 1 over 2e. Okay, so yes, if you substitute the actual x value in, you can still work it out. You just need to be really good at logarithms. Okay, if you're really good at logarithms and exponential, then you can still work it out. But of course, the smarter way is just to substitute the convenient version in. Okay, any last question?
No.
Now, question 2. Let's get started on question 2. So these questions, the algebra, it's a little bit difficult. So if you're stuck, look at my answer. Just start from 2a. Okay, for the interest of time, we only do 2a, b, and c.
Can you have an ln of 1?
Yes, ln of 1 is equal to 0. Log base anything of 1 is 0.
Does that just mean that x equals 0? I don't know what I've done. Because if I have... Because when you write it up, then your derivative is 2e2x minus 2, and then it turns into 2 equals 2e2x, then you divide it, and then it's just 1 equals e to the power of 2x.
Yep.
And then to find x, you change it into logs, and it's 2x equals ln of 1.
Yep.
So it's just x to 0? Because you...
Yeah. Yeah, that's right.
Then the y coordinate is 0.
No, not 0.
Oh, 1.
Yeah, it's 1. Any questions, Sarah?
Can you go to
Which question are you on? A or B?
B, but how do you get where the 3 go when you derive B?
So when you derive v is 1 over 3x, and then you derive what's inside, which is 3, and then you cancel them off. Got it, Charlie? Oh, good. Don't see. Oh yeah, that's a cost one.
Wait, so when sine is 0, that's like 0.
0 is one of them, yes?
Yeah, it's 0 pi.
Mm-hmm.
Yeah, okay. Oh, but it's a negative domain as well.
Yes, that's right.
So how do you do the negative ones?
It's just the negative of the positive version. That's the easiest way to think about it. Alright, so if you're talking about sine equals to 0, you're talking about this point and that point, right?
Yeah.
Yeah, so this point is will be 0 and this one will be pi, but when you go negative,
Yes, and you'd have 0 pi and 2 pi for the positive one.
correct?
And then for the negative ones, you just have negative pi and negative 2 pi.
Yeah.
Oh. Okay. And then, so when you do it for your y coordinates, you have like y equals cos of pi, or whichever one it is, but like if it's just y equals cos of pi.
Mm-hmm. It's just using this value here, right? 2x equals to those values. So you look at cos of those values. So 0, pi, 2 pi, negative 2 pi. It just alternates between 1 and negative 1. Oh, wait. Yeah, cos of those, yeah.
Okay.
There will be 5 answers, 5 stationary points for question C. Yeah. 90% of method students won't be able to do question C. I guarantee you. You give it to, if you just want to torture your friends, just get 20 of them, or get 10 of them, and give this question to them, only one of them will be able to do it, or maybe even 0. This is not an easy one. Okay, no question, Sarah?
No.
Are you on C yet? Okay. So the next one that we'll go through is example 35. So Charlie, you can have a read at example 35 and see if you can understand that. It's in there, next page, example 35. Let me compare that.
I hate these questions, Corey.
I know. These are the non-straightforward one. You gotta think.
How do you transition from like sine 2x to the like?
To just the 2x values,
Yeah.
like this line here. Oh, wait. Like this line here. So sine of 2x equals to 0. We're solving for what values of 2x would give sine equals to 0, right? And it's these 2 points here, right? Because those 2 points, the y coordinate is 0, right? Which means, and then you need to read off what angles would give, would those 2 points represent. So it's just pi, 0 and pi, and then 0 and pi, and then 2 pi, right? But then in the negative region, you just need to read the negative version. So it's negative pi and negative 2 pi. All right, let's continue. So I'll start explaining example 35, but I will do a little bit different. So the textbook gives you the solution. I'll tell you guys the thinking process, right? The thought process that you guys need to have in order to do the question like this. So the curve has this equation here. It passes through the point 0, 5. So we've got a point here and has a stationary point, right? So the stationary point location is at 2, 7. Find A, B, and C. When there are 3 variables, how many equations do we need to solve these? For each variable we're trying to find, you need 1 equation. So 3 variables means you need 3 equations. How do we form 3 equations here?
How do you substitute like each point into original?
Yep. Okay. Okay. I'll give you the 3 pieces of information that you need. Okay. So how do we use the point 0, 5?
Define C.
Yep. Or in other words, it's sub x equals to 0 and y equals to 5. How do we use the information that there is a stationary point at 2, 7?
I find when like
Stationary point, so what?
when like the derivative is 0.
Mm-hmm. And when x is?
Oh, 2.
Yep, when x is equals to 2. And then the last one is sub x equals to 2 and y equals to 7, same as the first one. Right? So you see, using each of these information, you will be able to find one equation. Sometimes, like in this question here, one of them you will be able to find an answer straight away. But in harder questions, you may not be able to find one of the variables straight away. You need to use simultaneous equations. Okay, so number 1 here. So step 1, step 2, and step 3. Using step 1, you would get you would sub x equals to 0, y equals to 5. Then you get 5 equals to 0 plus 0 plus 0 plus c. So then you get 5 equals to c straight away. Okay, so that's step 1. Step 2, we need to substitute dy dx equals to 0 when x equals 2. So we actually need to derive it first. We need to find the dy over dx first. So that's 3x squared plus 2ax plus b. Okay, and then sub, or you can write this on as y dash, sub y dash equals to 0 when x equals to 2. Right? Then what you would get would be 0 equals to 3 times 4 is 12 plus 4a plus b. Okay? And then step number 3, right, is when you would substitute x equals 2 and y equals 7. Alright, so then we would get 7 is equals to 8 plus 4a plus 2b. And then plus c, which is 5. Okay, so you get 2 equations now. We need to solve both a and b, and we have 2 equations. How do we solve them simultaneously?
You make one of them the subject and substitute into B also?
Yes, that's one way of doing it. Then that's called substitution. In this case, I'm going to show you guys elimination method. Okay, so next would be the elimination method for solving simultaneous equations. So first, for equation 1, I will leave it as it is, but then for this equation, I will change that into, I'll move all the numbers to the left hand side. It doesn't really matter, but I'll move it to the right hand side. Sorry, right hand side, that will be 0 equals to 6 plus 4a plus b. Right, so I'll actually use this equation instead. Okay, all right, 0 equals to 6 plus 4a plus b. This is, I'll call that equation 2, and I'll call this one equation 1. So elimination method is you take equation 2, subtract equation 1. Okay, and I'll write it as equation 2, so that's 0 equals to 6 plus 4a plus b, subtract equation 1, which is 0 equals to 12 plus 4a, I think this one should be 2b plus b. And then when you subtract them, what is eliminated? Charlie, what's eliminated?
4a.
4a, correct. 4a will be eliminated, right? When you subtract, it's gone. And then 2b minus b, which is be 1b, equals to negative 6. And 0 equals to negative 6 plus 1b. So then 6 is equals to b. Yeah. Okay? Yep. And then you substitute that into any equation. So you sub b equals 6 into, and you can just use any equation. I will choose equation 1 here. Right, into equation 1. So I will get 0 equals to 12 plus 4a plus 1b, which is 6. Yep, and then you solve for a. Right, so that's 18. Move the 18 over, negative 18 equals to 4a. So then negative 18 over 4, that's negative 9 over 2 equals to a. Right, and then you write down the final answer. Therefore, a is negative 9 over 2, b is 6, and c is 5.
Yay.
Alright, made it. Any question?
No.
When you
Yeah, Sarah?
How do you go from like the second equation to like make it so 0 equals 6?
Yep. What about it?
How did you get there?
Move the 7 to the other side. So 8 minus 7 is 1, and then you plus that to 5 is 6. Right? I'm just combining all of the constant terms on the right hand side. Okay? Alright, let's try one question. One question, and we'll take a break, Charlie. Okay? Just one question. Okay. Just question 7. Alright, just the last one. Question 7, and then we'll take a break. And then we'll move on from this chapter. This terrible chapter. Alright, question 7. Let's go. Don't worry guys, question 7 is like exactly the same as the example. It's almost exactly the same as the example. So you can breathe through it. So Charlie, just grind through it. You finish question 7, you're done for the first half anyway. Alright, that's the full answer for question 7. And I'll stop the first half of the recording now.